So now here we start our B part, that is similarity and dissimilarity in fit. Now the questions brief outline how to compute dissimilarity between the student's feedback profile. Now we got the sub questions like nominal attributes. So now what is nominal attributes? Use the simple matches or distance is equal to 0 if some category 1 if different for multiple nomination attributes. Aggregate sum of matches oblique sum of attributes, or use the Gover's distance for mixed data. Alright, now if category has similarity structure, use the category similarity matrix. Now here we got the asimilarity binary attribution. Use jacket distance for two binary vectors. Jacket dissimilarity 1 minus number of attributes both 1 and oblique the number of attributes where the least one is equal to 1. Now see numerical attributes. Use normalized distance so each attributes comparable. Alright. Now the Euclidean distance on the normalized standardized values, that is called, or the Manhattan distance. The Mahalanobis distance to the account for the attribution correlation. Now the D1, the term frequency convert to TF, IDF or normalized term frequency vector and use causing similarity. And the Euclidean distance on normalized vector. For the sparse text, use cosines because magnitude difference are less important. Now the question 6, that is here again. Suppose two student faculties interact profile are the represent as tuples. Compute Euclidean distance, Manhattan distance, Minkowski distance with h is equals to 3. H is given and the supreme distance max norm then between two profile. Here given two numerical tuples A1 and AD up to AD and B is equals to B1 to BD. Alright. Now Euclidean D2, that is under root summation range D I is equals to 1 then AI minus B whole square. Now the Manhattan D1 is equals to, here also the same range is given, that is mode AI minus BI. Now Minkowski H is equals to 3. Here again, here is the mode of AI minus BI and it is given the whole cube and then 1/3 the power 1/3 supremum max mode AI minus BI. Now the question 7. Here is the question 7. The median score is often used as holistic indicator of faculty or the infrastructure performance when dealing with the massive students feedback dataset. Propose method of the median approximation, analyze trade-offs and suggest heuristics to balance accuracy and efficiency. Here are methods: streaming quantile algorithm, Greenwald Khanna T-digest approximated quantile with the bounded error using small memory, good for the one pass streaming. Now the second one, reservoir sampling plus abstract quantile on sample, that is simple but accuracy depends on the sample size. Alright, now the third one, distributed aggregation Compute local histograms, quantile summaries, and merge. Use quantile sketches that merge well. Example T-digest. Now the fourth one, bean-based histograms. Main fine grains histograms, beans, and approximate median from cumulative counts. Memory times trade-off depends on bean size. Now the last deterministic selection algorithm requires random access data, not streaming but exact with the linear time. Here are the trade-offs and heuristics. Often you can see 4 points are there. If the strong accuracy required, use the mergeable sketches or the exact distributed short. For the DexBot where the small errors okay, use T-digest with the small memory. If data are skewed, outliner, prawns, prefer robust algorithm and update its sketches. And the last heuristic, maintain two heaps that max heaps or for the lower half and main heaps for the upper half. For this exact medium in the online scenario where memory can hold half of data, otherwise use a sketch. Now the eighth question. Here you can see the question that is considered the student faculty similarity analysis, a simple data set of the two students shown in the table 1 in that table. Then here is the and what we have to find out the rank existing student feedback profile similarity using Euclidean, Manhattan supremum and quotient similarity. Normalize students vector length and recompute Euclidean distance. Now here is the answer. The image vector and the query dimension were hard to interpret. Now we can see quotient similarity, that is A dot Q upon A mod Q mod, ranked by the largest quotient. Euclidean and Manhattan as defined. As you can see in in the previous question, I have already defined the Euclidean, Manhattan and supremum distance. So here for the normalized vector, each student vector by the Euclidean normal and the recompute distance. Alright. Now